Wake up, grab your smartphone, turn on your smart TV, adjust your smart thermostat. We are constantly surrounded by technology marketed as smart, but we tend to use the term artificial intelligence as a catch-all phrase for almost anything with a microchip and a power button. Take an automatic washing machine. You set the parameters, it fills with water, and it spins. It completes a physical task by following a rigid set of pre-programmed instructions. It is executing a script, not thinking. What about an air conditioner you can turn on from an app while driving home? That device is simply receiving a digital signal over the internet. That is a concept known as the Internet of Things, or IoT. If these everyday devices are not truly intelligent, what actually is? To identify artificial intelligence, we first have to look at the biological version and define exactly what makes humans smart. This chart shows how researchers break human intelligence down into 9 distinct categories.
Someone might be highly skilled in mathematical logical reasoning, while someone else possesses advanced linguistic or spatial abilities. If we look at the core of these different traits, we can distill intelligence down to 3 foundational capabilities required to operate in the physical world: the ability to interact, the ability to reason, and the ability to learn and adapt. Of those 3 traits, the absolute center of intelligent behavior is how we reason through a problem to make a decision. This illustration sets up a hypothetical survival scenario to test that exact process. You are trapped in a room, and you have to pick one of these 3 shrinking doors to survive. Making the right choice here isn't a random guess or a flip of a coin. Your brain generates a calculated prediction by analyzing the available information and applying your past experience to the environment. Look at the specific threats given in the text. Behind door number 1 is a lake with a deadly shark. Door 2 hides a psychopath with a weapon, and door 3 contains a lion that has not eaten in 2 months. The safest route is door number 3. A lion that hasn't eaten in 2 full months would already be dead. To solve that puzzle, your brain took the raw facts presented, combined them with your existing knowledge of biology, and deduced the safest logical outcome. True artificial intelligence is built to replicate this biological process. Instead of lived experience, a machine ingests thousands or millions of data points, processing them to deduce the best possible outcome. Early on, the system will guess incorrectly and hit a wall, but it rapidly adjusts its internal pathways after every failure, much like a baby learning to walk through trial and error, until it consistently finds the correct answer. This document highlights how this continuous intake of training data powers the digital assistants we rely on daily. By tracking what you click and how long you look at a screen, platforms build custom models of your behavior, recommending specific products you are likely to buy or adjusting your map routes based on live traffic updates. These systems earn the label of artificial intelligence because they independently update their internal models based on continuous data intake, rather than executing rigid code. Armed with that definition, we can finally draw a firm boundary between actual learning machines and the basic automation we looked at earlier. A fully automatic washing machine requires human intervention to select the parameters for every single load. Because it cannot adjust its own settings based on the clothes you put inside, it is simple automation. That smart air conditioner still relies entirely on you pressing a button in an app to power on. It is an internet-connected device waiting for a human command. A machine crosses the boundary into actual artificial intelligence when it has been trained on data and can autonomously optimize its actions without our intervention. Today, this autonomous software is being placed into advanced physical forms designed to navigate the human world directly, like Sophia, a highly sophisticated humanoid robot. When you merge the predictive learning capabilities of AI with the physical reach of robotics and connected IoT networks, our homes, power grids, and transit systems begin to adapt to our needs in real time. Ultimately, a machine's intelligence isn't measured by the pre-programmed task it completes for us today. It is measured by its capacity to analyze its environment and learn how to do that task better tomorrow.